Graph sketching, we're going to add asymptotes. Let's sketch the graph of this function here.
Okay, we could talk about the graph.
What'd you say?
We're getting golf if we don't have enough paper.
You know it, man.
Because I so just took that last one like this time in online
All
paper.
year. I'm doing it anymore.
It's an easy fix. Okay. When you see a rational function, your alarm bells for an asymptote should immediately go up. Ding. That's rational, right? So we have a possible asymptote. Where would that possibly be?
0 or
Where would a vertical asymptote possibly be? Just looking. Possibly at 2, right?
Yeah.
So there's a possible vertical asymptote at x equals 2, right?
Right.
How do I in fact know that's a vertical asymptote?
Set the bottom equal to 0.
Okay, yeah, so that's how we got 2, right? It makes the denominator 0. How do I know for sure that it is a vertical asymptote?
The graph?
Can I factor anything out of the top?
No.
No. Right, so because I cannot take 2x out, 2 out, if I put 2 in, so 2 in numerator,
That gives you 8. Oh, you do 8, yeah.
gives you 8, right? So we know that that in fact is a vertical asymptote. If you plug 2 in the numerator and it gives you 0, that's just a whole point discontinuity, right? So because this gives you a number, vertical asymptote, check. Okay? Good with that? I think we've probably hit it 5 times this year at least. How do I determine horizontal asymptotes?
Your numerator equals 0.
No, that's just 0.
Right.
Think back into hallowed antiquity.
It was
Huh?
What was that?
It was when it was something, or it was like 1 over
Infinite
Something over-
limits.
Oh.
And we have to do the other way as well. Negative infinity. The other way. Yeah. That way and this way. Positive way or negative way? No way. Oh, we just go no way and be done with it. Good one. Okay, limits. How do we solve infinite limits?
The highest exponent, solve for highest exponent.
Yeah.
Hey guys,
Way to go.
3 over 2, right?
Yeah.
3x over 2x, so 3 over 2.
Right.
Okay, what about this one?
And we have, wait, no, it's still 3.
No, negative.
It's still positive.
Okay.
So a horizontal asymptote.
3 halves.
Let's make it a y equals. Caught myself that time, I guess. Okay, so we know where our asymptotes are. Yes, Kyra?
So, this is going to sound totally dumb. But
Probably not, but okay, I'll listen.
But, so it's like when the
Well, they could be different and you'd have two asymptotes. These are the same thing,
How
but
we?
they don't have to match.
Okay.
If they do not match, you get two asymptotes. Okay.
Wait, how would they not?
Yeah.
Match it.
You laugh.
When you
How
get
would they
into
not?
squareds and square
Oh,
roots and all
okay.
sorts of stuff like that, negatives start to play a bigger role.
Valid. Oh, okay.
Okay.
All right, so,
Question is.
yeah,
More negative.
the uglier. It's not a word we use when we talk about mathematics.
Wait, I thought when you're solving infinite amount, it's, you just take the highest exponents and then cut off the exponent.
Yeah, but you have to consider,
So if it was
that's
like
the wrong button.
3x, oh, if it was like 3x squared over 2x?
Yeah, then it'd be 3x over 2.
Yeah, so one would give you a positive, the other would give you
But
a
if it's like
negative.
3x squared over 2x squared, you can just reduce those to 3x over
They would
2x.
still be the same, yeah. Okay, so we have a horizontal asymptote at 3/2
Alright.
and a vertical asymptote at 2. Now we're going to use derivatives to determine positive, negative, increasing, decreasing concavity, right?
Right. Oh, this isn't quotient.
Yep, quotient rule. Fortunately, it gets a little, simplifies. So low
2x minus 4.
times,
Wait, what are we doing this for? Can we use what the following rule?
we are done with the limits.
Wait, then what are we calculating for?
We are now trying to figure out where this function is increasing and decreasing and has critical points.
Okay, so you're just doing f prime of x?
Yeah,
Okay.
that's,
It was just out of nowhere.
no, it wasn't.
Didn't you use?
I staged it properly. What for?
The derivative?
Is that a limit?
Oh, no.
No, no L'Hopital's rule. Okay, low, d high minus high,
D low over the
2
square.
3x
what's the
minus
top?
3x plus 2 times 2 over 2x minus 4 squared.
Okay. Simplify it.
So 3 minus 3 minus 3x. Yeah.
Why is that negative?
Didn't you just say?
Negative distributed.
Can't you just have simplified 2x minus 4 times 3 to 3?
No.
What?
Can't you just?
Distribute.
Oh, I know, but can't you just take the 2x minus 4 out?
Why?
Did you have the 2x minus 4?
Yeah, but you don't have one over here.
Yeah.
They are separated, you would just kill the puppy dog with an algebra atrocity. Shame on you. You have to have a 2x minus 4 here if you want to factor it out. It's becoming our most common error. Who was your pre-calculus teacher?
You.
Mr. Reimer.
You're gonna get the whole lot next year. I'll guarantee it.
People like to play
The students that I got from Mr. Reimer in pre-calculus are the best students I've had in pre-calculus ever. So we will not talk trash about his abilities as a math teacher.
I love that guy.
He's odd, but he's a good math teacher.
He's odd.
I'm glad.
It's good.
Okay, so
Said I was glad you got better.
does that ever equal 0?
Yes, no.
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 Okay,
Yes.
Maybe.
No.
never equals 0 because the top never equals 0, right? So there are no critical points. But is there a spot where the derivative, where we are not differentiable?
Yes.
Where?
Two
Where is
or,
our
yeah, two.
at x equals 2, right? Because of the denominator.
Right.
Okay, so we have to do a sign analysis on that still. Pick numbers, whatever. Yeah, so no equals 0, but we still have to consider where it's not differentiable. Okay. F prime at 0 is negative. Here's the beautiful thing.
Negative 1, 4.
Is this ever going to be positive?
No.
No. We get a positive always on the bottom, and the top is always the negative. So this function is decreasing across its entire domain. We're going to see a concavity change, though. Okay. So when we do f double prime,
Oh.
I don't see what concavity change, but I'm just saying.
do you want to do the quotient rule again?
Not really.
Yeah, but it'd be like value.
Okay, I suggest then that we rewrite
Oh, increase in the positive. I see.
the negative exponent. Am I going too fast?
Ever so.
Not.
But I'm.
Yes.
Not the chain rule.
Okay, I will stop for a minute to let you catch up.
How can something exclusively be decreasing by a concavity change?
You're about to find out.
Is that it?
Negative.
The graph of that.
Yeah.
How about this?
That's always decreasing the concavity change.
Did I show you the logistic equation the other day? A couple weeks ago?
No.
That was BC.
Wait,
Okay.
is log logistic? Is that where the log comes from?
No, that's logarithm.
Oh, okay. I thought I was on
A little bit more musical. Okay, this is a chain rule problem now.
Yeah.
Yeah, so 8 times 2x minus 4 times
Don't forget your exponents. So we do the power rule, copy, and then,
yeah.
so we get 16 over 2x minus 4 cubed.
Yeah. That's good.
Boy, this is a triple extended pager. I love these problems. Could that ever equal 0?
No.
Okay, but is there a place where it's not differentiable again?
Yeah.
X equals 2. So we do our sign analysis, same deal.
Okay.
We're in the second derivative now.
What's that? Yeah, that's negative and positive.
Negative,
Yeah, negative.
positive.
Is that what you want?
It's just what it is. It's not about what we want. Sorry. This is just kind of what life's handed you. You just kind of take it. I don't want to lose my job. Well, yeah.
Here's like.
Okay, so concave down to concave up, right? So we have decreasing concave down, and we have increasing concave up. You know what a rational function looks like, right? Remember 1 over x? Looks like this. That's positive, correct? So it's going to follow the same pattern as 1 over x.
Oh.
Does that match our first and second derivative criteria?
Yes.
Yes.
Okay. So if I would have drawn it here, Would this have matched our criteria? No,
You're doing
it wouldn't have,
complicated.
right? So those criteria tell you where to put your graph. And it's just a sketch, we're not being exact. Okay, so there you go. Rational function determining asymptotes.
It's a lot longer than
Well, you add a limit, couple limits in there, it takes a little longer. There is another it's the same drill. Okay. Are you done copying? I'll take that as a yes.
Dude, we're doing two separate pages.
I know, right? That's an eraser. The book's -1, but it doesn't matter. Same process for this one. You know what? Let's definitely make that -1. Where are your vertical asymptotes?
one, negative one.
1 and -1.
Yeah, because if you plug 1 or -1 in, it gives you 0 in the denominator. Can't factor, right? How about horizontal asymptotes?
Wait, always do that.
Yeah, definitely, all that. So,
What's the highest exponent on the bottom?
x squared, so
And there's-
1 over x squared.
Right, so 1 over infinity
Right.
is
0?
0.
Good job, Mom.
Okay.
Oh,
And then you're going to go through and do your first derivative and your second derivative. Okay. And you'll figure that it looks like this.
What?
Cool.
What? Huh?
How did you get that?
Okay, so
Show your word.
do you want me to do the derivatives and everything?
Yes.
Go through, okay. I thought it would be okay if I didn't, but.
So if you just put that like on the test, would you get credit?
For a sketch like that?
Well,
No, you wouldn't.
so you have to show your work.
Yeah, so you're gonna have to show your limits.
Oh, you can't just be like, oh, it's 1 over x
Yeah.
squared, it's obviously 0.
You just have to, you have to show them that you know what to do to get the horizontal asymptote, so. Okay, infinite limits, then your derivative, okay, so I've turned this into a chain rule problem now.
Okay.
So what is the derivative?
So negative x squared minus 1 to negative 2 times 2x.
So we get 2x over x squared minus 1 squared. Critical point,
On negative 1.
x equals 0.
0.
And we're not differentiable at positive or -1, right? Slow down.
You did the same thing in the third class though? Like you could set denominator equal to 0.
Yeah, that's what it is.
Well, yeah, but you have to like actually write all that.
You could probably get away without doing that.
Figures yourself.
All right, sign analysis. So f prime at -2, f prime at negative 0.5,
Oh,
f prime at 0.5, f prime at 2. And we should get
That.
positive. The bottom's always positive, right?
Yeah.
So all we have to worry about is this.
that's positive, positive.
Positive, positive, negative, negative. Does that match?
Yes.
Increasing, increasing, decreasing, decreasing. Right. Do you want me to do the second derivative? It's messy. That's okay. Okay, this has to be a quotient rule. I could make it a product rule. Do you care which one?
I like quotient.
It doesn't matter. It's, I mean,
That's what I'm doing right
okay.
Because we're not gonna have the foresight to change it.
Okay, quotient rule. There, we do the quotient rule because there's an x here. The first derivative, there was no x in the numerator, so I could make that a nice chain rule problem. But here it has to be a quotient or a product.
now. Oh, so if you just put.
So if you put this up here with a negative exponent, it turns it into a product rule. Thank you, Nick. So low, d high, minus high, derivative low. Jeez. Over. I said derivative, and she thought it was hilarious.
No, I cry every single day in this class. It's happening right about now. She does. She put her there.
Why?
No, it's every day though.
Just an automatic, like, major response.
Because what?
Yeah, it's me, you're gonna cry.
I have that right before this.
I'm sorry.
Pretty accurate.
I don't want her to cry.
Wait, is that, wouldn't that be x squared minus 1 to the 4th? What?
Oh, yeah, it would.
Oh, on the bottom.
X squared minus 1 squared squared?
Square.
Thanks for that.
Ah,
Told you to watch it. Okay, this top
It's messy.
be plus, and we have 2x times 2 times 2x, which is 8x squared times x squared minus 1. You have to, we have to set this equal to 0 and solve. The hope will be that some things cancel out. Just be honest.
Solve this terrible equation.
FOIL, right? X to the 4th minus 2x squared plus 1.
Yeah.
And distribute
Here's the 4th minus 8x squared. Over.
leave it.
Okay.
No es necesario.
Is that funky looking thing on the bottom of the 4?
Yeah.
X squared.
Same 4 that's right there.
Why didn't you know if you changed it?
Why would I change it?
Because it does
I don't just change stuff magic. It's like, poof, it's now an 8.
Try, stop yelling. I don't know.
That's math murder. It is.
Okay, this is getting ugly.
This is painful to look at.
You guys are starting to get giddy, and I know that's when it's time to be done.
Please.
So,
We're giddy all the time. We're just happy to be done. I don't know about Cairo.
because I'm happy. Okay, let's not.
There you go, Mr.
You gonna start dancing?
Yeah, just start dancing and singing out of stream. I'll even give you your guitar and you can start playing too.
It's just become.
Here's what's really
We're on
freaking cool.
What?
It proves sometimes that math is just a big waste of time. When I set this equal to 0,
Right.
You get the first answer we got.
x is positive or negative 1, which is the same as
That's the difference in doing it
where it is not differentiable. All that algebra for nothing.
Wait, this proves.
All of this is painful.
So, just negative 1, 1, f double prime, f double prime,
Don't wait.
we should get
Wow.
Wait, can you put an inflection on the asymptote?
yeah. So these are asymptotes, correct?
Yeah.
Is there a concavity change?
Yeah.
That is a point of inflection.
You got too late.
All right, so now you see where we get everything. No crying. Let's start being like Miss Teeter. Cry here! David. Negative 1 and 1. Okay. Yeah, that was a messy deal, but it happens.
It's painful to look at.
I'll switch over to this.
I'm literally.
And it's not even like and it's not even like it's process, it's just
You can't go punch him. Come on. Dump it.
Here it is. Did not give you a whole lot.
Oh my god. I physically can't.
5 problems.
that's wrong.
Is it on the
Probably not as difficult as the one we just did.
We already got it.
My notes right here in front of me say this is supposed to our classroom. I have to check. It's the same as we did Friday. You're looking at derivative, second derivative, you just add the asymptotes to it. Okay? Okay, and I would say we only have like one more day of learning things about derivatives. They're called slope fields.
Wait, I'm not really sorry about derivatives though.